All right, so these are the notes for distance, midpoint, and circles. Our essential question is, how do you find the center and radius of a circle in the coordinate plane? All right, your first main idea is going to be distance, so write that in the left-hand column. And here's the distance formula. So it's the square root, and then you'll have two sets of parentheses squared. You subtract the x's in the first parenthesis, and then square that, plus the y's subtracted in the second parenthesis squared. And this, the x sub 2 and x sub 1s and y sub 2, y sub 1s, those are the ordered pairs. So the x's go together subtracted in the first parenthesis squared, plus the y's in the second parenthesis squared, all under the square root. The squareds and the square root do not cancel because of this plus sign inside. So you can't just find these two numbers and add them together and then think that the squares cancel, because it doesn't. Okay, so let's review how to plug into distance formula. So it says find the distance between these 2 points. So basically this is the structure that you're setting up every time you do distance formula. Now let's fill in what we have. So we've got our x's are -5 and -3. You could either do -5 minus -3, which will be +3, or you could do -3 minus -5, which would be -3 plus 5. In the end, we'll get the same answer, so the order doesn't matter. So I did -5 minus -3, so now I'm going to do 2 minus -2, which is actually 2 plus 2. All right, so then I get -2 squared, and 2 plus 2 is 4 squared. So -2 squared is +4. So even if you get a negative in the parenthesis, when you square it, it will become positive. So that's why the order didn't matter of how you subtracted them. And then that's 16. So you get the square root of 20. Now, the choices, though, would actually break this down. So remember, the perfect square that divides into this is 4. You could do the square root of 4 times 5, square root of 5, so that would be 2 times the square root of 5. So that's the answer you would pick. If all the choices were decimals, well, then you would just do the square root of 20 and then pick that decimal. Okay. All right, so in the column right midpoint, the left-hand column right midpoint, this is our second main idea for today. And so here's the midpoint formula. And the midpoint formula is when you add the x's and divide by 2, and then add the y's and divide by 2, and that gives you the ordered pair of where the midpoint is located. So midpoint, you add the x's and the y's, and you have to divide by 2, whereas distance, you subtracted the x's and the y's in separate parentheses and squared them. Okay. All right, so example 2. Find the midpoint of the line segment joining -5, 2 and -3, -2. So when they give you 2 points and they say find the midpoint, then we're going to use the midpoint formula. So I'll just use capital M for midpoint. So we add the x's. So my x's are -5 plus -3, and then divided by 2. My y's are 2 and -2. 2 plus -2 divided by 2. Okay. Well, that gives me -8 over 2. That gives me 0 over 2. So then -8 divided by 2 is -4. 0 divided by 2 is 0. So the midpoint is located at -4, 0. Okay. All right, example 3. Write an equation for the perpendicular bisector of the line segment joining -5, 2 and -3, -2. Okay, so perpendicular bisector, I'm going to break down the word. So what does bisector sound like it does? The bisector is going to cut it in half. And then perpendicular means it intersects to form a right angle. So this would be an example. So if I have some segment, and in this example, our segment has endpoints at -5, 2, -3, -2. I'm not actually graphing it in the right parts on the number line. I just am trying to show you what's going on. Okay, in red, I'll draw the perpendicular bisector. So a perpendicular means it has to form a right angle, and bisector means it breaks this, it goes through the point that breaks this in half so that these two pieces are congruent. So that's what these slashes are showing, is that the length from this endpoint to this point is equal to the distance from this endpoint to this point. So if these 2 points, or if these 2 segments, these 2 smaller segments have to be the same length, what does this point have to be on the line segment? Has to be the midpoint, because the midpoint is the point that divides the segment into 2 equal halves. Okay. So we need to find the midpoint because our line in red has to go through this point. Whatever that point is, has to go through that point, and we have to figure out what the perpendicular slope is to this segment. So upside down T represents perpendicular. So once I find those 2 things, then I'll plug it into y equals mx plus b, and then that'll give me my equation. So what do you think we need to find first? Okay, let's go ahead and find the midpoint. And remember, we just did the midpoint formula for this actual problem. So -5 plus -3 divided by 2, 2 plus -2 divided by 2. Remember that gave us -4, 0. Okay, so then that means -4, 0 is the point that this line has to go through. Okay, next, we need to find the slope of the segment. And we need to find the slope of the segment because once I know the slope of this, then I take the opposite reciprocal to get the perpendicular slope. Okay, so remember your slope formula is y2 minus y1 over x2 minus x1. Okay, so let me subtract the y's. So I'll do 2 minus -2, which is actually 2 plus 2, all over. So I did 2 minus -2, so I have to do -5 minus -3, which is actually going to be -5 plus 3. So that'll be 4 over -2. So the slope of this line is -2, or the slope of the segment is -2. All right, then our third step is going to be to find the perpendicular slope. And remember, I'll put in parentheses that perpendicular means it's the upside down T. So find the perpendicular slope. Well, remember, it has to be opposite of this, so we're going to change the sign, and then we flip it. It's opposite reciprocal. So what's the opposite reciprocal of -2? Positive 1/2. So perpendicular slope is going to be positive 1/2. It's opposite and it's flipped. So that's the slope that we're going to use. Now I'm going to use this slope, 1/2, that's the perpendicular slope, and this point, the midpoint that this perpendicular bisector has to go through, so I can solve for b, and then I can write my equation. So my y value is 0, and that we're going to use is 1/2, times x is -4 plus b. So that's 0 equals -2 plus b. So b is 2. So then my equation is y equals the slope, 1/2 x, plus 2, that's your b. That's the equation of this perpendicular bisector of this particular segment. So then some steps here I didn't write down, but we actually did. So once you find the perpendicular slope, then take the midpoint and the perpendicular slope to solve for b in y equals mx plus b. Then step 5, get the equation. Once you solve for b, then you've got the slope and you've got the b, so you can plug it in to write the equation. Now for multiple choice, you would probably be able to get it down to 50-50 at this point. Once you find the slope, maybe you do slope and do the perpendicular slope first instead of doing the midpoint first. That's fine. Then you would realize the slope is 1/2. So by choices, you'll be able to get it down to a 50-50. Then you would definitely have to know to find the midpoint. And then once you have that point, you could plug it into your two choices that you have it narrowed down to see which one works. All right, the last example for midpoint is if one endpoint of a segment is at -5, 2, and the midpoint is at 3, -3, find the other endpoint. So this time, this is the situation we have. And again, I'm not actually putting it in the coordinate plane in the correct spots, but this time we're given one endpoint and we know the midpoint, and we're trying to figure out what this other point is. So you can't just plug this into midpoint formula. You can't do -5 plus 3 divided by 2 and then 2 plus -3 divided by 2, because that would give you the midpoint between these 2 points here. That's not what we're finding. This is actually the midpoint, and then here's an endpoint, and we're trying to figure out the other endpoint. So you have a couple choices. One choice is we could set up an equation, two equations, where I take this x plus this x, so -5 plus x divided by 2, and that has to equal the x value of the midpoint. And then I would solve, multiply by 2, add 5, that would give me my x value. Then your other one, you could do the y's, so add the y values, 2 plus y, so 2 plus y divided by 2, and that has to equal -3. So then multiply by 2, subtract that 2, and then that would give you your y. So that's one way you could do it. The other way is the snowman method, where the head of my snowman is the given endpoint. The middle section of my snowman is the midpoint. And then what I'm trying to find is this endpoint here. Okay, so then you ask yourself, what do you do to the x's from here to here? What would I do to -5? What would I add or subtract to -5 to get to 3? Well, we would add 8. -5 plus 8 gives me 3. So whatever you do there, you have to do again, get the next x value, because it has to be the same distance away. So 3 plus 8 gives you 11. Okay, here we would subtract 5. 2 minus 5 gives you -3. So you have to minus 5 again. So -3 minus 5 is -8. So then 11, -8 is that other endpoint. Oops, there we go. That's the choice you would pick. If you solved here, you would have gotten the same thing. If I multiply by 2, I get -5 plus x equals 6. Then add 5. So x equals 11, which is what I got. Here, multiply by 2. 2 plus y equals -6. Subtract 2, y equals -8, which is what we got there. So whether you decide to do it the equation way here or the snowman method here, you're still going to get to the same answer. And you can always check yourself. So then -5 plus 11 is 6, divided by 2 does give me 3. 2 plus -8 is -6, divided by 2 does give you -3, so it checks. Okay. All right, so then when you go to the last page, or the next to last page there, circles is your main idea. This is our last main idea to go over. I put some definitions in there for you. So a circle is the set of all points in a plane that are equidistant from a fixed point called the center, which we're going to use as HK. So you have your center, and then the circle, all of these points on the circle are the same distance away from that point, that center point. The radius is if we go from the center to any point on the circle. That would give you the radius. The standard equation of a circle, so go ahead and copy this down. You have parentheses x minus h squared plus parentheses y minus k squared equals the radius squared. So this h and k represent the center, and then the r represents the radius, but we actually square it to put it in the equation. All right, so on this first one, when you have to graph, and really for multiple choice, you would have to pick the graph that's correct. So let's pick out the center and the radius, and then that'll help us graph it. Okay, so remember you have your h and your k, and this is supposed to be a minus sign. The original has minus signs in it. So when your original equation has minus signs in it, then it looks like it's x minus 2 or negative 2, but it's actually the opposite. So the x value of this is positive 2, and this is supposed to be a minus, so it's actually negative 1. Because for this to be, you would have had y minus negative 1, which is why it becomes plus 1. Okay, so it's always opposite. Your center is always opposite what's inside the parentheses, and your x value is the number inside with your x, so I change it to 2, and your y value is the number in the parentheses with y, which is opposite, so it'll be negative 1. Now remember that number at the end, that is actually the radius already squared. So I know that r squared is equal to 16, so how do I get r? Right, we just square root both sides. So the radius is 4. All right, so I'm going to plot the center, and then I'm going to count the radius out 4 in the 4 directions, vertically and horizontally. So I'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then you've got your circle there. So if it was multiple choice, you would definitely look for the one that's centered at 2, negative 1. And then if it gets you down to a 50-50, you've got to count for the radius. Okay, I didn't count diagonally or anything because if you get those 4 points, then it's easy to sketch. And that's how you pick out your center and your radius. Okay, this one, we want to write the equation of the circle. And they're telling us that the center is at 4, negative 1. And it passes through the point negative 2, negative 3. Now, if you look at the equation, what are the 2 things we have to have in order to write this equation? You have to have the center and you have to have the radius. Okay, then once you have those 2 things, you can write the equation. So we're missing the radius. Well, I can write an equation with the center in it. So I could write a parenthesis x minus 4 squared, because remember it looks in the parenthesis opposite of what it is, plus, then I could do y plus 1, because it'd be y minus negative 1, which is plus 1, or think of it as the opposite. The only thing we don't know is r, so I can say that equals r squared for now, but at least I've got the left side where they gave me the center. So what do you think I would do with this point in order to solve for r? All right, let's plug it in. So I'm going to plug in the negative 2 for x. Everything else stays the same. And then for the y, I'm going to plug in negative 3. And everything else stays the same. Well, now I can solve this. So negative 2 minus 4 would be negative 6 squared. Negative 3 plus 1, negative 2 squared. So negative 6 squared is 36. Negative 2 squared is positive 4. So r squared equals 40. So I don't really need to know the radius because now I'm going to go back to this equation that was up here and just copy this side, stayed the same. And I just take that radius squared number and put it there. So this is the equation of the circle given in example 6. So they give you the center, so go ahead and fill that in, but you don't know r, so leave it as r squared. They gave you another point though that the circle does pass through, so plug that in for your x and y on the left side. So you can solve for r squared, then put that in your equation and you're done. All right, example 7. Write an equation of the line tangent to the circle, x squared plus y squared equals 13, at the point 2, -3. So tangent line intersects the circle at one point and is perpendicular to the radius. Okay, so let me sketch a picture of what's going on here. So we have our circle, and then a tangent line would intersect the circle at one point. And then if you draw the radius from the center to that point, it's going to always create a right angle. Well, here, if I plug in the given information, our center, since it says x squared plus y squared, there's no parentheses. That means our center is at 0, 0. And it says the tangent line to the circle at point 2, -3. So it intersects the circle at point 2, -3. So that's this point here. Okay, and the center is at 0, 0 because there's no parentheses squared. So that means that h and k were both 0. All right, so we're trying to write the equation of this tangent line. So remember, if we're writing the equation of a line, I'm going to do y equals mx plus b. So I need the m for this line. And then I also need the b for this line. So that's what this point is going to help us with. Okay, so I know it has to go through this point. The only thing I'm missing is that perpendicular slope, because remember, this is going to be perpendicular to this radius. So since I need the perpendicular slope, I have to find the slope of this segment, because once I know the slope of this segment, then I can do the opposite reciprocal to get the perpendicular slope. Okay, so let's do the slope of the segment. Subtract the y's on top, so 0 minus -3, and then the x's on bottom, so 0 minus 2. That's 3 over -2, so -3/2. So when you do opposite reciprocal on this, what will the perpendicular slope be that we care about? Positive 2/3. Okay, let me write the slope over here that we did. All right. So now I'm going to use this slope and this point to write the equation for this tangent line. Okay, the y value is -3. The m is 2/3 times the x is 2. -2 is just 2 plus b. Okay, so when you multiply this, leave it in fraction form because that's how your choices are going to show. They're not going to give you decimals. So this would be 4/3 if you type that in. Now to solve for b, I subtract 4/3. And then when you subtract that in your calculator and it gives you a decimal, remember you hit math, enter, enter, and then that would give you -13/3. So now I've got enough to write the equation. So I'm going to write y equals this slope, the 2/3, x, and this b minus 13/3. Okay? So for a tangent line, it intersects the circle at one point, and they gave us that point. And then it also showed in here that the radius the center of the circle is at 0, 0. That's important because you have to find the slope of this segment so that then you could do the perpendicular slope because the tangent line is perpendicular to the radius. So we did the perpendicular slope, use that slope, that point that it went through on the circle, and solved for b so that we could write our equation. Again, you can probably get this down to a 50-50 if you do the slope piece and then plug in this 2, -3 into which ones are left if you don't do all of this. All right, I wrote some steps here, but it'll make sense if I actually do the problem, and then you can refer to this later to remind you of what I did, okay? Because notice that this is asking you to put these in standard form, and we have to state the center and the radius. You cannot state the center and the radius with it looking this way. Remember, we have to have some parentheses squared with x plus or minus something. Then you have to have a parenthesis with y in it plus or minus something squared. And then it's got to equal some number squared. Okay, this does not look like that right now. So the first thing you need to do is group all the x's and y's together. So put the x's first because that's what comes first. I write x squared plus 8x. And then we're going to do plus blank, okay, because we're going to have to complete the square here. So we're going to review that. You did that in Chapter 4 in Algebra 2A. So that's your y group. Then you have a plus a blank. Now I do my that's your x group. Now we do the y group. So plus y squared minus 10y. And again, you'll do plus blank. Now, if there's any numbers left over without an x or a y, you're going to move it over to the other side. So I'm going to minus 5. So that would look like that. Now, eventually, we're going to add two numbers on this side. So whatever you do to one side, you have to do to the other side. So that means if I have two blanks that I'm going to add over here, then I have to have two blanks that I'm going to add to this side of the equation to keep it balanced. Okay, next. Oops. I'm going to focus just on the x piece. So I'm going to put that in red here. Okay, so to complete the square, you take the b value, which is 8, divide it by 2, and we're going to square that number. So what's 8 divided by 2? 4. And 4 squared is 16. So I'm going to add 16 here to make a perfect square trinomial. And if I do that on that side, I have to do it on the other side of the equal sign. This is important because now this factors into x plus 4 squared. And that 4 came from what you got when you did b divided by 2. I got positive 4 here. Because if I were to take this, if I were to factor this, you would get x plus 4, x plus 4. That gives you 8 in the middle when you add 4 and 4, and then when you multiply 4 times 4, you get 16. So that's important because remember in the standard form of the equation, you need a x parentheses squared. And I've got an x with a parentheses squared. Okay? All right, now let's do the same thing for the y group. So you take the b value, -10 divided by 2, and we're going to square it. -10 divided by 2 is -5, and then square that, which is 25. So we're going to add 25 here, and whatever I do on one side of the equal sign, you must do on the other side of the equal sign. So This is going to be y minus 5 squared. And it's minus 5 this time because when I took b divided by 2, negative 10 divided by 2, I got negative 5. So negative 5 plus negative 5 is negative 10. Negative 5 times negative 5 is positive 25. All right. Then go ahead and just add this stuff up. So negative 5 plus 16 plus 25 is 36. So this is the standard equation. You took it from this original form, which you couldn't tell the radius and the center from that, and turned it into the form that it's supposed to be in, 2 parentheses squared equal to a number. Okay, so then the center is at negative 4, 5. Remember, it's opposite of what it looks like. And the radius is 6. So probably how they'll ask you is either ask you for the center and radius, or maybe one or the other, and you would have to put it in standard form first in order to be able to answer that. Okay, and you'll notice that each of the x squared and the y squared had a positive 1 in front, which is good. So I didn't have to do the extra step that I'm going to have to do on part B here in a second. All right, so on part B, let's go ahead and group like we did before. So I put the x stuff first, 2x squared minus 4x, and then we're going to do plus something. So that's my y, or my x's. Now let's do the y's. Plus 2y squared plus 8y plus blank. And that's going to equal, now we have a number that doesn't have a variable with it, so remember we need to move that over. So it's going to be 8, and then we'll have 2 blanks. All right, now part of the first step is to make sure that you have a 1x squared and a 1y squared. So then what we need to do is divide this 2 out of all of the terms that we have so far. You don't have to do it of the missing terms here, but you have to do it of all the terms that you already have. So then that would give me x squared minus 2x plus blank plus 1y squared plus 4y plus blank equals 4, and then you have your 2 missing blanks to keep the equation balanced. All right, I suggest you pause now and see if you can do part B, and then start it back up when you're ready. All right, if I do the x's, you should have done negative 2 divided by 2 squared, which would be negative 1 squared, which is positive 1. So you add 1 to both sides. And so my x's will be x minus 1 squared. Because again, how I get the minus or the plus here, it's whatever b divided by 2 came out to be, which was negative 1. Okay, now let's do the y's. So you should have done 4 divided by 2 squared. So that's 2 squared, which is 4. We have to add 4 to both sides. So my parenthesis then is y plus 2 squared. Because again, we got 4 divided by 2 was positive 2, so y plus 2 squared. Then we'll do the math over here. 4 plus 1 plus 4 is 9. So you should have gotten your center to be at 1, negative 2, and your radius to be 3. And then this is your equation. So again, they may ask you for just the equation, so then you would pick the right equation, or they might ask you for the center or the radius, so you'd have to get that out of the equation. Okay. All right, so these are the notes for distance, midpoint, and circles. So make sure that you do your repetitions to help you prepare for the test, the final exam. If you have questions, you can come see me before school or after school tomorrow, Tuesday. So this last finals week, I'm available Tuesday before and after school. I'm also available Wednesday before school, and possibly Wednesday after school. You just gotta let me know. Okay.